Hi, I'm Emily from emilylearning.com. So in this video, I'll be going through 2023 CJC Prelim Math paper. This is a paper 2, question 7, and we'll be covering question on permutation and combination and probability questions that involve using concepts from permutation and combination. So let's get started. Let's take a look at this question on permutation and combination. So in this question, you're given in a class of 18 students. There are 12 girls and 6 boys. A chairperson, a vice chairperson, and a secretary are chosen from the 18 students. So chairperson, vice chairperson, and secretary are different positions or different roles. So if you have 3 people, A, B, and C, okay, or you have 3 students, student A, student B, and student C. Okay, student A being a chairperson is a different event from student A being a vice chairperson. So very likely we are looking at permutation because these 3 positions or these 3 roles are different. Okay, so now let's look at A. So find the number of ways the chairperson, the vice chairperson, and the secretary can be chosen so that they are all girls. Okay, so to find the total number of ways so that they are all girls, okay, it means that we are going to choose the 3 rows, okay, from these 12 girls, and then we are going to permutate them because these are 3 different positions. Okay, so number of ways is equals to 12 choose 3. Okay, so after choosing 3 students out of these 12 girls for the 3 positions, they are different positions, right? So I need to times 3 factorial. So this will give me 1320. Moving on to part 2, there are at least 1 girl and at least 1 boy. So you are going to choose 3 people for these 3 positions. Okay, and you need at least 1 girl or at least 1 boy. So if there are 3 people and you need at least 1 girl and 1 boy, there are only 2 cases. So case 1, you have 1 girl and 2 boys. And case 2, you have 1 boy and 2 girls. Okay, so let's find the number of ways where 1 girl and 2 boys are chosen. Okay, so to choose 1 girl, you will take 12, choose 1. To choose 2 boys, you take 6, choose 2. And because these positions, chairperson, vice chairperson, and secretary, there are 3 different roles, so you need to times 3 factorial. So this will give us 1080. Next, we look at case 2 where you have 1 boy and 2 girls. So to choose 1 boy from 6 boys, it is 6 choose 1. To choose 2 girls from 12 girls, it will be 12 choose 2. And because these are 3 different positions, we need to multiply it by 3 factorial. This will give us a value of 2376. So the total number of ways, okay, we'll just add the number of ways in case 1 with the number of ways in case 2, which will give us 3456 ways. Okay, next, let's move on to the next part, B. The 18 students sit at random in a circle for a lesson. So they are going to sit in a circle. Okay. Find the probability that the chairperson, the vice chairperson, and the secretary are separated from one another. Okay, so for this question, if someone is separated from others, we generally like to use the slotting method. Okay, so what we'll do is we'll let the other students sit first before we slot the chairperson and the vice chairperson in. So there are 18 students altogether. Okay, and we have these 3 positions. So in other words, there are other 15 students. Okay, they do not mind sitting anywhere. So we will put the students first. So there are 15 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, then the vice chairperson, the chairperson, and the secretary will be slotted in between any of these positions. Because once you slot them here, they will be separated by at least one student, right? Okay. So in other words, right, how many slots are available for these three people to sit in? Well, there are 1. So I'll start counting from here. So I put a dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 slots, right? Okay. So to find the number of ways, okay, where the chairperson, vice chairperson, and secretary are separated from one another, okay, it will be equals to, first I'll sit these 15 students, right? So to sit these 15 students in a circle, the number of ways will be 15 minus 1 factorial. Okay, now I have set down these 15 students, okay, in a circle. Next, I'm going to slot the chairperson, vice chairperson, and the secretary into one of these slots that are in between the other students. And there are 15 slots altogether. So out of these 15 slots, I only need to choose 3 slots. Next, the chairperson, the vice chairperson, and the secretary are different people. So I need to multiply by 3 factorial. All right. Okay, this is going to be a very big number, so I will not evaluate it yet. Okay. Okay, reason is because they're asking for probability, not number of ways. So this is the P&C type of probability questions. So to find probability, you first need to find number of ways for given scenario over total possible number of ways, right? So in this case, the numerator, to find the probability, we will take number of ways for the given scenario, which is the chairperson, vice chairperson, and secretary are separated from one another, divided by total number of ways of sitting the 18 students in a circle. The total number of ways of sitting 18 students in the circle will be 18 minus 1 factorial, right? Total number of ways to sit 18 students in a circle. I'll not write the inner circle because it's very long. So I'll take 18 minus 1 factorial, which is 17 factorial. So the required probability okay, it'll be equals to the number of ways from the given scenario, okay, which is here, this 15 minus 1 factorial times 15 choose 3 times 3 factorial, okay, then divide by total number of ways, which is 17 factorial. So let's do it. Choose 3. Okay, so evaluate this in the calculator. You'll give a value of 91 over 136. Okay. Okay. Now let's move on to part C. Okay. So in part C, you are asked to find the probability that there are exactly 2 girls sitting between each boy. So in other words, right, it's 2 girls, 1 boy, 2 girls, 1 boy, 2 girls, 1 boy, and so on, right? Okay, so there are many ways to do this question. Okay, you can think of it as, right, the 2 girls are always separated by a boy, or the boys are always separated by 2 girls. So when it is a separated by type of question, you can use the slotting method like what we did in part B. Okay, so I'll use the slotting method for this question, right? Because the 2 girls are always separated by the boy, by a boy, or the one boy is always separated by the two girls. So you can either slot in the two girls or you can slot in the boy. It is the same, okay? There's no difference. So what I'll do is probably I'll slot in the two girls first, okay? And because there are 12 girls, okay, and two girls sit together, so in other words, there will be 6 groups of 12 girls. So I'll sit down the 6 groups of 12 girls first. So girl, girl. Second group of girl and girl. Third group of girl and girl. Fourth group of girl and girl. Fifth group of girl and girl. And 6 groups of girl and girl. So 1, 2, 3, 4, 5, 6. So total there are 12 girls now. Next, I'm going to slot in the 6 boys, right? In between the two girls. So I'll have a boy here, 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 and a boy here. So 6 slots. 1, 2, 3, 4, 5, 6. 6 slots altogether. Okay, so let's find the number of ways where 2 girls sit between each boy. Okay, so what we'll do is we will first sit these 1, 2, 3, 4, 5, 6 groups of girls in a circle. To sit 6 groups of girls in a circle, it will be 6 minus 1 factorial because it's a circle. Next, okay, we are going to choose 2 girls for each seat and then permutate them, right? So I'm going to choose 2 girls. So I'll start off with this here. So let me highlight the one that I start off with. So I'm going to choose 2 girls here, okay? So the number of ways to choose 2 girls will be 12, choose 6. Okay, then these 2 girls, they can be girl 1 and girl 2, or girl 2 and girl 1. So the number of ways to permutate them is 2 ways, right? So I need to times 2. So to sit these 2 girls, it will be 12 choose 2 times 2 factorial, or I can just write it as 12 permutate 2, okay? 12 choose 2 times 2 factorial is the same as 12 permutate 2. So I can do that, or I can also do this. So I'll just take 12 choose 2 times 2 factorial. Then to sit the next 2 girls, now after sitting 2 girls, I have 10 girls left, right? So it's 10 choose 2 times 2 factorial. Okay, then after choosing 2 girls followed by 2 girls, there are 8 girls left. So it's 8 choose 2. Then I can permutate them. They can swap position. So I times 2 factorial. Okay, then I have 6 girls left. So it's 6 choose 2 times 2 factorial. So I've done this, I've done this, I've done this. So there are 6 girls left. So now 6 choose 2 times 2 factorial to choose these 2 girls and sit them. Okay, because they can swap position, I need to times 2 factorial. Then I do the same for here. It will be 6 choose, so 4 choose 2 times 2 factorial. Okay, because only 4 girls left. Finally, only 2 girls left. So it's 2 choose 2 times 2 factorial. Okay, so I'm done with the girls. Okay, then next, I need to multiply by the number of ways that I can sit the boys. So there's 1, 2, 3, 4, 5, 6. 6 slots available. And the boys, all the slots will be occupied by the boys, right? And the boys can swap position, can permutate among themselves. So the number of ways to sit these 4 boys, these 1, 2, 3, 4, 5, 6, 6 boys, okay, will be 6 factorial. Okay, I will not evaluate it for now because later on it's going to be a very big number. Okay, so I'll just evaluate it later. Okay, when I divide by the total number of ways. So because I need total probability, it will be the number of ways for that scenario, which is 2 girls sit between each boy. Okay, which is this number of ways. Okay, then to find probability is total number of ways for a given event over the total possible ways. We have already found the total number of possible ways in part B, which is 17 factorial. So the required probability, okay, is basically equals to 6 minus 1 factorial times 12 choose 2. Okay, times 2 factorial times 10 choose 2 times 2 factorial times 8 choose 2 times 2 factorial 6 choose 2 times 2 factorial 4 choose 2 times 2 factorial 2 choose 2 times 2 factorial times 6 factorial over 17 factorial. Okay, put this into the calculator. You type everything together inside your calculator. You get 1 over 6188.